Welcome to lecture series on database management system. In today's lecture series, we are going to see about deadlocks. So deadlock mainly occurs when there is a concurrent execution of transaction. So we will discuss about that topic today. So now look at this graph. T represents the transaction, whereas U represents T and U are transactions. So T is one transaction and U is another transaction. A and B are resources which is being used by those two transactions. So what do you infer from this graph? Now look at this graph here. Resource A is held by transaction, whereas this transaction is waiting for another resource B. That particular resource B is held by transaction U, whereas U is waiting for transaction A. So what can you infer from this graph? A resource which is a transaction is waiting for a resource which is held by another transaction. So both the transaction is experiencing the same scenario. So transaction T is waiting for a resource B which is held by U, whereas U is waiting for resource A which is held by transaction T. So there is a loop which prevents any transaction from uh, getting completed. So this kind of graph is called a circular weight graph. So circular in the sense it shows a loop. It shows there exists a loop, right? So weight represents a transaction is waiting for a resource which is held by another transaction. So this kind of situation is called as, or this kind of scenario is called as deadlock. Now, this is an example for the graph we have seen earlier. Now, look, there are two transactions T and U. So before this, we have already seen what is shared lock and what is exclusive lock. So shared lock is for obtaining only the read lock on a particular resource, and exclusive lock obtains both read and write lock on a particular resource. Here transaction T deposits 100 rupees into account A, which means it has obtained write lock. So write lock on particular resource called as A, after which transaction U is depositing 200 into B, which means it has obtained write lock. Now transaction T is withdrawing 100 rupees from B. It wait for U transaction to happen. It withdraws 200 rupees from A and it issues a lock on A. Parallelly, transaction T issues a lock on B. So when from this transaction, what you could have, from this concurrent transaction, what can you infer? Transaction T locks A. Initially, it locks A and it waits for U to release its lock on B. U, on the other hand, it locks B initially and it waits T to release the lock on A. So this is a circular wait. A transaction has obtained a lock on particular resource for which another transaction is waiting to be released. So this kind of transaction exhibits circular hold and wait, which is called as deadlock. So this is another example for deadlock. Uh, for a deadlock to occur, it is essential to ensure that there should not, there should not be any shareable resource. If there are any shareable resource, deadlock will not arise. All the resource has to be uh, exclusively used only by one transaction at any time. It should not be shared. So only then deadlock will arise, and there should not be any preemption on locks, and there should be a hold and wait or circular wait scenario that is existing among the transaction and resource. Only then the transaction is bound to deadlock. So these are the various scenarios, various conditions for a deadlock to occur in a concurrent transaction. So what are the strategies if deadlock arise and we cannot leave deadlock as such? So there should be some strategies to fight deadlock, right? So here are some of the strategies to avoid, to prevent, not to avoid, I can say, to fight against deadlock. So deadlock, it can be prevented, or if in case it occurs, it can be avoided. Or in the initial stages, we can even detect occurrence of deadlock. So what is meant by deadlock prevention is that uh, it violates any one of the necessary condition of deadlock. What are the necessary condition of deadlock we have seen? So we have seen there should not be any preemption. The resource should not be shareable, and there should be a circular way. If there is any such scenario, we will avoid the transaction. So thereby we can prevent deadlocks. So deadlock has already occurred. How can we avoid the deadlock? Uh, Initially, we can define the transaction in such a way that it requires maximum number of resource that it need to be used, uh, and those resource can be locked at any time. So for them to be used. So this kind of thing is called as the banker's algorithm. So banker's algorithm is used for deadlock avoidance. This you would have studied in your operating system as well. This is common for operating system as well as for DBMS. Next is deadlock detection. Deadlock detection is finding ways to detect the cycles in wait for graph, and if there are any cycles that are found, and finding out strategies to abort them, uh, abort the transactions that are in cycle. This is deadlock detection. So there is another thing called as optimistic concurrency control, which is given by Kung and Robinson. Uh, we have earlier seen that locking protocols have two-phase locking protocols have various problems like dirty read problem, lost update problem, inconsistent retrieval, and many. Uh, so this optimistic concurrency control is mainly used to avoid the conflict that occurs in two-phase locking protocol. So it says that we need not worry about it is a myth. We need not worry about the conflict, and we can keep doing whatever we are doing. And only if any problem arises, we need to worry about it. Till then, we need not worry about it. This is something skeptical thing. It is not a technical thing. So here is an algorithm for optimistic concurrency control. There are three phases in this algorithm. First one is working phase, second one is validation, and last one is update phase. In the working phase, each transaction will hold the tentative version of the object that it is going to update. Mm, So this tentative, it acts as a view. So when we are discussing about SQL, we have seen table and view, right? So this tentative version act as a view of the transaction. So any update that is made to the transaction, tentative version, and if we need to abort it, we can abort the tentative transaction, which will not affect the actual object. So this is a working phase. In the validation phase, we check the transaction for any conflicts with any conflicts. And in the update phase, once the transaction is validated uh, of all the tentative object, that particular transaction is made permanent. So here are the various validation rules. Uh, to transaction, and or we have written the conflict pairs. So we have mentioned only the conflict pair of transaction because we have nothing to do with the non-conflict pair since it will not arise any issue. So the first conflict pair is write and read, uh, which if there is a pair like this, the transaction TI must not read the objects written by TV. Similarly, if there is read and write conflict pair, TV must not read objects written by TI. And for write and write conflict pair, TI must not read the objects written by, must not write the object written by TV, and TV must not write the object written by TI. So vice versa should not happen in case of write and write conflict pair. So here is a summary of what we have discussed throughout in this lecture series. We should increase concurrency because it improves the throughput of the server. So concurrent execution is very useful because it saves the time and also throughput of the server. If there are any inconsistencies or deadlock, it is essential to detect those inconsistencies and deadlock and prevent them as early as possible. And uh, so this validation phase, previously we have seen the validation rule. It is essential to make the transaction uh, to make the transaction read abound. So that's all. So few of the examples. These are few of the examples for your practice, which we will do it in the class. Hope you understood what is a deadlock and how to avoid it, how to prevent it, and how to detect it. Thanks for watching and keep watching the remaining part of the lecture series.